Hello, Professor Sargent here with you again, and now we're going to take a look at piecewise functions, analyzing if we are given the rule or the equation for it, and as part of that coming up with a graph, versus being given the graph, analyzing that, maybe trying to work backwards and find out the equation if possible. So here we go. This example, we have three different intervals. And when we're asked for the domain, if we just lump these three intervals together, starting at -4, there's an or equal to there. And there was no or equal to with the 2, but it gets included here. And then in the third interval, you keep on going. So we've got x greater than or equal to -4, which in interval notation, we'd have square bracket at -4, comma, infinity, with parentheses at the right-hand end. As for intercepts, the y-intercept, remember, is when x is equal to 0, and that occurs in the first interval. 0 is at least as big as -4, but strictly less than -2. We put in 0 there. 0 plus 5 is giving us 5. So we've got a y-intercept at 0, 5. As for x-intercepts, you want y to be 0. And remember that f of x is a fancy stand-in notation for y. In that second interval, for just a brief moment, when x equals 2, y is equal to 3, not 0. So we're not going to get, at that moment, an x-intercept. We want to look on the first interval if we can ever have y equals 0. And there would be a solution to that equation, but -5 is not in the interval. It is one unit to the left of where it started, so we'll reject that. And for the other interval at the far right, we do get x equals +7, and that is bigger than 2, so 7, 0. We can use that and perhaps find some other points to graph the piecewise function. So we should aim to see in the x direction at least from -4 to +7. I'm going to go just a little bit beyond that. These are going by ones, just so I don't fill up the space too quickly. I'm labeling by 2s, leaving some of these unlabeled. So, x plus 5, we know that we're getting a y-intercept at 0, 5, and there's a slope of 1. I'm going to work backwards here. Down 1 and right 1. There is a segment of what we would see on that interval. But first of all, 2, 3. That means that starting at -4, included with an closed circle there, this is going to keep on going. It's going to keep on going to 2, 7, in fact, but that will not be included because we're told the function's definition, when x is 2, y is equal to 3. Then we also found out that on the last interval that we've got an x-intercept at 7, 0, the slope is -1. So if I go back to 6, 1, that will be down 1 and right 1 to the 7, 0. And I'm going to continue that back to here. Although it doesn't follow this rule when x equals 2. When x equals 2, y is equal to 3. But it's going to go right on up to that, to the point -2 plus 7, that's 5. So we've got an open circle there as well at 2, 5. So based on the graph, this, by the way, is going to keep on going forever. It doesn't appear as we look from the bottom up that there is ever a minimum that it would hit, but it would go up to, yet not include, because of that open circle, it would go up to 7. Parentheses around the whole thing, -infinity, 7 appears to be our range. And because we have these breaks and these holes, we do not have a continuous function. More specifically, there is a discontinuity at x equals 2. Discontinuous at x equals 2. Got one more for you coming up in just a moment. So we'll be right back after this break.